Hello, this is Frank Baumgartner. I am an application engineer at the Duluth office for Cognex. Today we're going to be talking about ModBus communications and DVT Intellect 1.4.1. This topic actually is not specific to just version 1.4.1. It's pretty much the same for all the previous versions of Intellect. But this is the most recent version, so that's what we'll be using. So in general, we're going to go over the basic way of initiating ModBus communications between a camera and another device. In this case, I'll be using the Intellect emulator to communicate with another DVT camera, also running 1.4.1. And we'll talk a little bit about how to do both reads and writes, and look at how to maybe trigger a camera using ModBus, and that'll about do it. So let's dive into it. So what I've got here is Intellect 1.4.1 loaded with some images. I'll flash through those real quick. You can see they're images of just rings, washers, something like that. I've got a area finding sensor. Object locate in particular is the algorithm that I'm using to find these and return an object count. So we can see that down here we have objects equals 11. If I trigger a new image, for this particular image, we get the same count, but if we go to this image, we see that this time we get objects equals 8, and in the last image, objects equals 10. So our goal is to write this result from this inspection out to another camera using ModBus. Now, the way we need to do that is to go into the Communications menu, which if you double-click on Communications, will bring up the System Explorer. Right now, I've got it tabbed so that it displays in the bottom. Now the entire Communications menu, or I should say the System Explorer, looks like this. If it displays like this, all you have to do is expand Communications and then just expand the ModBus TCP folder. If you look at the properties for ModBus TCP, by default it's probably already enabled and running, so you shouldn't have to do anything there by default. Now what we want to do is create a data value, and then we actually want to transfer that value. So the first thing we're going to do is create what's called a ModBus tag. This is very similar to OPC tags or tags that you might see in Allen Bradley Ethernet IP, something like that. It's just a representation of a value. So if we double click in this window, we get a tag created for us. I'm going to change the name of this to count. And I'm going to change the tag type to parameter, which simply means that the value of the tag is going to be drawn from a parameter in our system, as opposed to a monitor tag, which allows you to simply look at a value in your system rather than actually do anything with that value. And then a literal tag would be a value that you can hard code. So I could put a literal tag and set it to the value 7, and it would always be 7. This would be in the case that I want to set a value in memory, whether some other operation is going to access that, or whether I wanted to transfer that value to another device. Any reason you can find to do that, go for it. I'm going to set a parameter tag though. The start register defaults to 16 because bytes 0 through 15, or I should say registers 0 through 15, because ModBus uses 2-byte registers. 0 through 15 are actually reserved for system functions. They hold values like triggers, any other bits that have to do with system level functions. For instance, I/O functionality. There's some reserve registers that in there aren't doing anything. Product selection can be done through these bits, so we don't want to mess with those for now. So you want to write something after 15. So we'll start at 16. The data type I'm going to write is an integer, which is a 4-byte value. So in the ModBus world, since every register is actually 2 bytes, then the data length is going to be 2 registers. But right now you can see that the default for you for an integer is actually 4 bytes, so you don't have to think about that. And what we really want is to get our source expression. And the source expression is going to be from the tool that we have created. And you click on that ellipsis there, it opens up a parameter browser, and tool 2 is just the default name that was given to the object locate tool I created. If I expand tool 2, you see that object count is one of our options. I'm just going to select that, OK. And now we have a source expression. So our tag, now you see, is represented down here. Tag name count, parameter type, or I'm sorry, tag type parameter, value equals 8. integer data type. It starts at register 16 and it ends at register 17. So it's 2 registers long, that's 4 bytes. You can see that the number of bytes is represented over here, and then the source expression. So we got a value of 8, and that matches up with the value that we last saw. Now that we've updated this to 11, we come over here and we see that value has been updated to 11. So this is being updated, it appears, after each inspection. So we've gone back to 8, and we see that this is in fact gone to 8. Well, in fact, this is updating after each inspection, but now what we want to do is not just update that value, but actually send it out after each inspection. So what we're going to do is go to the ModBus Masters folder, and we're going to create a new ModBus Master. And all this is a set of operations that share communication settings specific to ModBus. So in this case, I'm just going to leave the default name ModBus Master 2. I'm not going to enable it yet. We'll come back and do that in a second. Start at power up simply means that it's going to start whenever the camera actually reboots from power down state. I need to give it an IP address. In this case, I'm going to be writing to another camera because I'm acting as the master. So I'm going to write to my other camera, which I'll show you here on my connections. I've connected to 2 right now. One is the emulator, which we're currently in, and one is the DVT 530. And I'm not doing anything with it right now. It's just all mine. I'm not taking images or inspections or anything like that. But you can see that the IP address is 192.168.0.10. So what I want to do is come over here to my ModBus Master. Oops, I'm on the wrong camera. Go back here. Come back to my ModBus Master properties, and I'm going to just put 192.168.0.10 as the slave IP address. So that means that for this ModBus Master, I'm going to be communicating with the slave device, 192.168.0.10. So that's my other camera. Now there's some other settings here that we're not going to change for now. But you can see that we can have a connection timeout in milliseconds, a send timeout. So this is actually the amount of time it takes to actually send the data. If for some reason there's a connection problem on the other end, these values will come into play. Receive timeout, same idea. Now the transfer mode is basically anytime we transfer data, either writing data to another device or reading data from that device, we can have it do that at a polled interval, which is controlled by this poll rate here in milliseconds, or anytime data changes, or polled and at the end of inspection, or just one of those. So polled, change of data, end of inspection, or a combination of those. So we're just going to leave it the default, polled and at the end of inspection. And you can see you just get some feedback here as far as the state of the ModBus Master. So right now it's stopped. So let's go into that ModBus Master, and now we actually want to create an operation. So if I double click here, I'm going to rename this write count. And for the command, we only have 2 options. I'm going to write slave registers, which means I'm going to write data to the slave values, to the slave camera's registers. Start register is going to be the location of my data, which remember was register 16. The slave start register that I'm going to write to, so this is on the other device, on the camera. I'm also going to write to the same register on the other device. And the count is the number of registers, not bytes. So we're going to have 4 bytes because it's an integer value, so that's 2 ModBus registers. So I'm just going to use a value of 2 there. And that's all I have to do for that. So now I've got a write set up within our ModBus Master, and now I just need to turn on that ModBus Master. Now before I do that, let's go over to the other device and take a look what's already there. Now if we come to my other camera, this is the one that's going to receive the data, and go down and look at the registers, we see that some of the registers may already have some data in them. So it looks like there's a system tag already up here at 11. We're going to ignore that. And it looks like there's already a system tag created at register 16. So I'm going to go over and delete that system tag, because we don't care about those. And I'm going to, okay, so that's all we've got there. Now let's go back to our product that we're working with. Look at those registers. And we see that register 16 right now already has a value of 8. So remember, register 16 and 17, 2 registers for 4 bytes. So that's got a value of 8 in it right now. So we want to see if that eventually changes. So let's go back to our source camera. I'm going to enable this ModBus Master. Oops, let's click there. So I'm going to turn that on to true. You see that everything grays out, so you can't edit it while it's enabled. You see that we're actually running now. If I go to my overall ModBus settings, you can see that we're running. And my count right now looks like it's 8. So if I trigger one, I've got a count of 10 now. So you see that here. Not only that, but if we go over to our ModBus tags, we see that this is updated at 10. If we look in still our source camera at register 16, we see that this is in fact updated to 10. So now we want to see if this has actually been transmitted to the other camera. And if we go to our other camera, we see that register 16 in fact now has a 10 in it. So we're good. We've gotten that to update. So now we've gotten something to write over. What if instead we don't want to just write a value, but instead we want this camera to actually read a value? So let me do a little house cleaning here real quick, just to be sure we don't have anything else interfering. So nothing there. We don't have any of the products. Alright, good. So now we're going to come over to our destination camera. And we're going to set up a tag, first of all, to make it a little bit easier to see our data. So this is going to be a monitor tag. So the first piece of data we sent over was the count. And this time we're going to monitor it just so we can see what's written there. It defaulted to our register 16, so we're okay there. Data type, I'm going to set this to integer. And the source expression we don't need because we're using a monitor tag. That's all we have to do. So now you see that this value is set to 10. So if we go back to this camera and trigger a new inspection, now the count is 11, you can see down in this register or in this tag. It's been updated. If we go to our destination camera, now you can see that this has been updated to 11. So we are in fact getting changes here. So this is good. We've got a good operation going. But now we want to demonstrate that we can actually, instead of having the data written from the master to the slave, instead, or I should say from the source to the destination, we want to instead set up a read operation so that the destination camera can read from the other camera. So we're kind of reversing roles here. So what I'm going to do is go to the ModBus masters, create a new ModBus master, and create a new operation. And this is going to be read count. I'm going to do a read slave registers. I'm going to read from register 16. This time I need to do a different register. I'm going to read into 18. And now I've got these backwards. I almost made a mistake. The camera that I'm on now that's doing the reading is actually the master now. So I want to read into my register 18 from the other camera's register 16. And the count in registers is 2. Hit OK there, or enter I should say. Come over to this ModBus master. The slave IP address that we're going to be communicating with was the IP address of our original camera. Now if we go back over here, you see that the original camera is on the emulator. So the emulator has an IP address of 127.0.0.1 when it's being referenced by the PC. But this camera needs to know the actual PC's IP address to be able to address it. So in this case, my PC's IP address is 192.168.0.2. So I'll come back over here, go to this ModBus properties, and I need to select 192.168.0.2. So that's the camera I'm going to be reading data from. And I'm not going to change any of this other stuff down here. Just going to enable this to true. So now that's running. You can see that all our settings are here. And now we're actually reading this value into register 16. So let's see what we've got down here for now. Register 16 has now got a value of, oh I'm sorry, the register 18. I said 16 before. So register 18 now has a value of 11. Now I believe this register actually already had some data in it, so let's be sure to prove that this is actually working. So I want to trigger this camera and see if we get any new data. Well, this still says 11, probably because this result is still 11. So let's get a new result. There we go. We've got a new result of 8 on this camera. Now we want to come over here, and it looks like we've got a value of 8 over here. So what has happened is this is automatically updated. We didn't even trigger it. And the reason why is because remember, in the camera that's doing the reading, we set up a ModBus master. Look at these properties. And the ModBus master is not just getting data after an inspection, but it's polling. So every 50 milliseconds, it's going out and grabbing data. So as soon as that data changed in the other camera, within 50 milliseconds, the live camera here that's doing the reading actually pulled that data in. And it's going to do the same after we actually issue a trigger. So if we didn't want it to do that automatically, then we'd have to come in here and stop this ModBus master by disabling it, and then saying, no, we don't want it polled, we just want it at the end of inspection. So now what we should see is that this register value, which is currently value 8, won't change automatically when we trigger this camera. So this goes to 10. We come over to this camera, and it looks like that did update. So what did I mess up? Let's go over to properties. I didn't re-enable this first of all. So everything was still as before. So now that's only updating at the end of inspection. This is doing a read. So this should only read when this gets to the end of an inspection. And let's come over to this camera. Trigger that. So now that's an 11. And we go to our registers. And our result value is 11 and 16. We come over to this camera and look at our registers here. And 16 now has 11. So one problem we're seeing here now is that these are automatically updating, and I have a feeling I know why. I was doing something earlier with this camera. Yep. So what I was doing earlier with this camera is actually something that we're going to do next, and I haven't erased those settings. So the next thing we're going to talk about, I'll explain this, why we're seeing this problem, is that I'm using the emulator to trigger the live camera. And I can do that by writing bits to certain reserved registers in the live camera. And the effect that that's having is that because when I trigger this camera, an inspection completes, one of the operations is writing a bit to my live camera. This live camera is getting triggered, and that is causing an inspection to occur, and thus this read operation completes over here and causes this register to get updated. So that's something that I should have deleted before we started this, but nonetheless you can see the functionality there. So since I brought that up, let's see how we would do that real quick. So what I'm going to do is go back to the emulator, and in this ModBus master, stop this real quick so that we can edit it. And go into this ModBus master, and we're going to create another write. And the value we want to write is a 1, and I'll tell you why here. Go into these tags, and I'm going to call this trigger. And this is going to be a literal value. It's going to start at 18. It's going to be a short, which means it'll be only one register long, and it's going to have a source value of 1. Now I'm going to go back and turn on our ModBus master. We'll go take a look at our registers real quick. 18, you can see, has a value of 1. So every time we do an inspection, I'm putting a value of 1 into this register. Now what I want to do is actually write that value out. So we go to our master. I didn't need to disable that and re-enable it before. I'm going to do a write, and this is going to be a write trigger. The command is going to be a write slave registers, and I'm going to write to register 11 in the other camera. And the reason I'm writing to register 11, if you go to the DVT script reference, let me zoom in on this a little bit, what you can view is the register mapping. And let's see if we can scroll this over some. And this is the ModBus register mapping, and these are the input signals for that register map. You can see that at register 11, what we have is the trigger bit at the very first bit. So if I write to register 11 a value of 1, then I'm putting a bit high here and all these others low. So this is kind of an easy way of triggering the camera. Now if you wanted to use some of these other bits, you'd have to take a different approach to this so you didn't set those all low. But if we set this to a 1, then we can actually trigger a camera. So I'm using a value of 1, and I'm going to write it to register 11. I'm sorry, this should be register 18 from the master to the slave register 11. And I'm only going to write one register in length. So now, I'm writing a trigger, length of 1 to register 11 in the slave camera, and it's going to have a value of 1. So I'm going to go back and turn on this ModBus master. And not only do I want to do this, write a value of 1 to the other camera, but I only want to do this at the end of an inspection. So I'm going to come down and say only at the end of an inspection. And there we go. We'll set that to true. So now, every time I write this, we should see a 1 show up in register 11 on the other camera. So let's go to our other camera real quick. Look at the ModBus registers. And now this has an 11 already. So what we want to do is set up some kind of way that whenever this camera gets triggered, it actually clears this back down to a 0, because we have to have an edge transition of 0 to 1 to get a trigger. So what I'm going to do is create a tag. I'm going to call it clear. I'm going to set this to a literal. And this is going to go into register 11 also. So this is in the destination camera that's being triggered. It's going to be a short, and it's going to be a value of 0. So this is going to actually clear out that value at the end of an inspection. So the process is the other camera is going to inspect. It's going to send a 1 to this camera. This camera is going to be triggered. It's going to inspect, and at the end of that inspection, it's actually going to clear this value down to a 0 so that it can be re-triggered later. So our source expression is a 0, and that's all we need there. This ModBus master is enabled. So let's see if we trigger this, and we go to look at our registers. We see that in fact register 11 has been cleared. So now, ideally, if we trigger from the other camera, this camera should increment its image ID. You can see it's at 17 right now. Every time we trigger, that gets incremented. So we want the other camera to trigger it. This image ID should increment, and then this should go back down to a 0 for the clear value. So let's go back to this camera, and we'll trigger this. We come over here, and we see that that's incremented to a 20. Come back to this camera and trigger it. Come to this one, and it's been incremented to 21. So now we're using ModBus to not only write data from one camera to another, but also to trigger another camera. So I can write a piece of data, have it sent over, and then actually trigger that other camera to potentially use that data. Now one problem you might notice is that in our source camera, we have these two operations, write trigger and write count. Now while these are in top to bottom order in this display, you can't guarantee that the trigger is going to happen before the count is going to be written, or vice versa, which means your camera may be triggered before it actually receives the data that it needs to use. So this isn't, although this is a possible way of doing this, it really just demonstrates the functionality that data can be written using ModBus easily using this setup, and it can also be triggered, although this is not the best way to trigger it because you don't know when that's going to happen relative to your data arriving. So instead of triggering it through this interface, we would instead actually want to trigger it by using script. So the script reference manual has information on the ModBus object. The ModBus object allows you to actually write a script that creates a ModBus object and connects to another camera, and then actually writes data to another camera's ModBus registers. So in this case, you could create a ModBus object that does the exact same thing that we did, but now you'd be able to control the timing so that you can make sure that trigger happens after the ModBus data has already been written. This can be used both in a background script and a foreground script. And you can see that there's some examples here on basically how to set it up. Just a new MB transfer is the way you create a new ModBus object. The connect function is very simple. You just give it an IP address. And whenever you want to do a write, you can actually just do your ModBus object.write, the master reg, which is just the register of the source data, slave register, which is the register of the destination and the other camera, the number of registers you're sending, and that's all you need. That's your source data, your destination, and the number of registers to send. Now you can also just write a coil, which is a single bit, which would be more practical for triggering a camera, since you don't need to write a whole byte or 2 bytes of data. You can just write a single bit. So this kind of demonstrates all the different ways you can use ModBus. I shouldn't say all, but some of the significant ways for sending data, for reading data, for maybe triggering a camera or doing other things in the system registers. Just to really quickly go over some of the other stuff in the system inputs for ModBus, you see that you can do a trigger over ModBus, you can do a product select over ModBus, you can actually send event counter values, which are used for counting up events, as the name indicates, to change the trigger mode, to change the inspection mode, to change or send a result acknowledge, so you can do some handshaking. You have digital relearns here that you can use, product ID bits, which are used with this product select signal, and then user inputs and user outputs in case you want to send whole chunks of data. In case you want to set I/O pins high and low on other cameras if they are mapped to user input. So there's a lot of different stuff you can do with this. We won't go into all of that. So just to recap, the basic process for creating a ModBus transfer is to first create an inspection that is outputting some kind of data. Next, go to the System Explorer, create a ModBus master, set the IP address and any other settings as far as timeouts and transfer mode. In that ModBus master, you actually want to create an operation. This can be either a read or a write. Select your master and slave registers and the length of data. This is the count. Optionally, set up a tag. Not always necessary. This data could be placed here from a script, but a tag is an easy way to get data from a tool into a register. That's all we've done with the tags. And then finally, just set your ModBus master enabled to true so that it can actually do something, and you're off and running. That's everything we have to talk about for ModBus. Hope you got something out of it. Thanks for listening in.